Hi everyone. In this video, we'll see what it means for a language to be regular. So we've seen regular expression and we've seen finite automata. And the statement for regular languages is that a language is regular if and only if there exists a finite automaton corresponding to that language. So we've seen that the definition of a regular language or a regular expression was that all symbols from our alphabet are regular expressions, and then we had a recursive definition which said that if I have two regular expressions, then their union is a regular expression, their concatenation is a regular expression, their the Kleene star of a regular expression is also regular. And if we wanted to prove the statement that an automaton exists for every regular language, then we can just take the definition of regular expression and draw the automaton for the base case, and then generalize the recursive part of it. So we can just show that if I have two automata, M1 and M2, then we can draw an automaton for M1 concatenated with M2, or M1 union M2, or for an automaton M, we can draw an automaton for M star. We just have to show all of this to prove that for every regular expression there can be an automaton. So in this video, what I want to talk about is where these regular languages are useful and where they fall short. So the place where these are very useful is if we just want to match some string. So for example, we might want to match someone's email address, and we can say that it could be any number of characters or digits, and followed by an @ symbol, followed by again any number of characters, not digits here maybe, so just characters, followed by a dot, and then again a few characters. That's what we can use a regular expression for. And another place in compilers that this is really useful is if we want to check, let's say, whether a number is a valid floating point number. We could say that it would be any number of digits followed by a dot followed by any number of digits. So we can say something like d star followed by a dot or an epsilon, actually dot d star plus epsilon. The reason I have that epsilon is because I also want to consider that 100 is also a valid floating point number. So I have a dot here. So this would be for a float. And similarly, I could check, let's say, whether some variable name that the user has given is a valid variable name or not. I could say that it is alphabet star. Actually, it is in most languages it would be alphabet followed by alphabet plus digit star. So this would be a valid variable name. So these are places where regular expressions are really useful. And of course, in the variable name, the alphabet also contains underscore. I would have to account for that as well, because most languages allow underscores in variable names, and underscore can be the first character in my variable. So this is where regular languages are very useful. But there are some cases where languages are not regular, and I'm just going to give you an example that I'm going to give you a language, and I'm just going to leave you saying that it is not regular. You could, of course, after this video, try and come up with a regular expression for it. You're not going to be able to come up with one, but you could try to come up with a regular expression or an automaton, a finite automaton. So what I'm saying is that a to the power n, b to the power n, where n is greater than or equal to 0. This thing is not a regular language. So the reason this is not going to be regular is just that in an automaton there's no way for me to keep count. So when I'm saying that both of these need the same n, so I need a to the power n and b to the power n, so this is not valid, but this is. So I somehow need to keep count of how many a's there are, and and after that just accept that many b's. And remember that in a finite automaton, the reason it's called a finite automaton is because the number of states needs to be finite. So keeping that condition in mind, this is not going to be a regular language at all, because this is not equal to a star b star, because a star b star would accept this one as well and this one, but I want this one right here to not be accepted. So this isn't a regular language, and for that we need some more rules, we need some different languages for it, and that's what we'll look at in the next video. So I'll see you there.